the session on Z&E buildings and the future of Z&E buildings. We're going to have it all worked out over the next 50 minutes. We are going to be so you're aware of the schedule. We're going to be ending at 12:30 here. I'd like to request that actually people, if you want to move on up, we got a lot of space here. There's a whole row. You guys can actually see what we look like a little bit better if you come up closer. So we got plenty of room up here. So I'm going to be setting the stage a little bit, and we're really going to have hopefully an interesting conversation about what Z&E means in the context of cities. And let me just peel back and say that I want to actually get a sense of who's here. Who's here from a city or city agency? All right. Who here is from a design firm? Anybody here from an engineering firm? And how about any startups or investors? All right. And then what group am I missing? I see independent consultants. Consultants. Anybody else? Academics, utilities, developers. All right, great. Thank you. I think we actually have a bunch of different perspectives up here on what Z&E is. And what we recognize is that the pathway to zero carbon and zero energy is going to be fought on many fronts. And clearly buildings are one of those fronts. What we're going to be talking about today is really how Z&E could and has fit into that conversation. I think that we're in a really different spot on Z&E buildings now than we were, I want to say, even 3 years ago. It's the conversation's changed, the technology's changed, the policy's changed, the economics have changed, not only on Z&E, but everything around Z&E. So what we're going to first do is just everyone's going to do a brief introduction of who they are and what they do, and how it relates to Z&E, and then we're going to have some focused conversation. This is going to be a conversation, and at some point, if you guys do have questions, please raise your hand. If how we're doing on time, we can definitely love to hear from you. So I'll start off. I'm Noah Goldstein. I'm a director at Navigant. We're a global consulting company. I work as part of the energy practice, focusing on sustainability and energy and technology. So why don't we just go to the line, Kimmy?
Does this work? Oh, whoa.
Oh, that's working.
Oh, that's working. All right. Hi, everyone. My name is Kimmy Narita, and I'm the acting director of City Energy Project. We are a national initiative to improve energy efficiency in large existing buildings across 20 cities in the United States, of which San Jose is, I'm proud to report, is one of them. So I work at the Natural Resources Defense Council, and then our partner group is also the Institute of Market Transformation. And within the portfolio of work that the City of San Jose is doing under City Energy Project is a Z&E pilot. As one of their innovative contributions to the program. And so I'm happy to speak to that and also to the greater portfolio of work happening across cities and energy efficiency.
My name is Cole Roberts. I lead the energy business for Arup in the Americas. We have about 1,500 staff in the Americas across about 8 offices. And our focus is on advanced urban energy systems, high-performance buildings, and connecting policy and practice for energy.
Is this working? Yeah. My name is Matt Golden. I'm a recovering efficiency contractor. Used to actually do work for a living. These days, work in kind of 2 areas. Run a project called the Investor Confidence Project, which is part of GBCI, folks that bring you LEED and GRESB and WELL and other standards. Which is a standard for investors to underwrite commercial and multifamily projects. So how do you know a good energy efficiency project when you see one? And then probably the more relevant work to this conversation, I run a company called Open Energy Efficiency, which is a data analytics firm that works with utilities and also companies in the marketplace to leverage smart meter data when it's available to quantify the impact of distributed energy resources, particularly on the demand side. So that we can send a price signal, figure out what is the actual value of things like zero net energy buildings as a grid resource in terms of reducing carbon and helping support our move to decarbonized sources of energy.
Great, thank you. And just for context, for those wondering, Kevin Bates couldn't make it. He had something he had to attend to, and so he couldn't make it today. So if you're wondering where Kevin is, he's not here. So actually, let me just start off actually with you, Matt, and I actually just want to try and get this conversation going. Is talking about Z&E really the right thing to do still?
So I think Z&E is a nice aspirational goal, but doesn't necessarily align with our current grid infrastructure and carbon goals. So it's not that there's anything wrong with Z&E at a fundamental level, but when we look at a day like today here in San Jose, where it's a nice spring day, the sun's going to probably pop out fairly well this afternoon. It's highly likely that in the 1 to 3 p.m. time period today, we'll be generating more solar than we know what to do with here in San Jose and across California, which means we're actually running what's called negative pricing, where we're literally paying generally Oregon, sometimes other states, to turn off their hydro and take our electrons. We have to pay them for that privilege. So in this context that we're moving into, actually not even moving into, that we are right in the middle of, if we want to create carbon and climate benefits, it's really a jigsaw puzzle that we're trying to put together. We are onboarding renewables at a pretty amazing rate, which is creating massive havoc in our load shapes. You've probably heard of the duck curve, and you've seen that little KISO graph that looks like a duck. It doesn't really look like a duck anymore. It looks like a pretty whacked out duck. It's about 4 years ahead of schedule and accelerating on almost every dimension faster than everybody expected year over year. We're also replacing grid infrastructure. Right now, PG&E is running an all-source procurement to replace a gas turbine in the middle of Oakland, and we have to do that without wires, which means storage, efficiency, non-carbon emitting resources. And then there's also massive efforts around electrification. Vehicles for sure, but also buildings. And so the zero net carbon conversation is kind of where we, I think, need to move. And there's a lot more complexity in this calculation in terms of what is actually beneficial and where do we maximize that and how should we invest in it.
Cole, what do you think in terms of you're working on some Z&E projects, but so you're also seeing what the future is and where we are on Z&E?
Right. So our perspective is that zero net energy has a remarkably and to some extent unfortunate deductive quality to it. That it underrepresents both the upside benefit of well-designed buildings, the net positive qualities that buildings can take on, and it to some extent takes too much. The reality is that for most, let's say for a residential homeowner or for a commercial owner, the cost of that zero net energy margin is remarkably small, and I would say insignificant for most, unless you're on a fixed income and you've got some other prevailing concerns. So for a cup of coffee, equivalent of a cup of coffee, the average residential homeowner can have a zero net energy, what I would say, off-site zero net energy compliant building. And that to me is a level of insignificance that for most people, they're just not even registering because it's just not worth the trouble. And yet we've had conversations like this that are about whether or not zero net energy makes sense. And that to me is a little bit of a discord in behavior. The other is that zero net energy has been locked into a conversation about buildings as islands rather than the broader goal of emissions reduction, which usually underpins the zero net energy dialogue. And what that does is create a conflict between transit-oriented development and zero net energy buildings. So you see the pilot projects that are out there, kind of the early movers, and they tend to be low-density buildings, not on transit corridors. And that is in direct conflict with what we really want to achieve, which is community-wide, I would say net positive or climate positive communities. So what we're arguing for is zero net energy to leave the building, to think more broadly about the implications of zero net energy, and to think about buildings not as zeros and negatives, but as positive contributors to society and wellness and so on.
Kimmy, what are your thoughts? I mean, you have a different take on you've been focusing more on energy efficiency than net zero necessarily.
Yeah, so for us from a city policy perspective, and this is a national perspective that I bring to the table, acknowledging that California is ahead, the leader in the nation on all things, basically all things energy. So the good thing about zero net energy buildings is that it's a bright, shiny, sexy thing to talk about, and if it gets people in the room and attracts the right attention to inspire energy efficiency policies more broadly, I'm all for it from a political standpoint. And that's the same thing that we see in the renewable energy front as well. Nobody actually thinks that energy efficiency objectively, unless you work in this field, is like a super sexy topic. You want the photo op with the solar panels. You want the photo op with the zero net energy building. You do not want a photo op with like an LED light bulb, unless you're, in the field like me. And so that politically is a huge appeal to continue to explore what zero net energy buildings can do in your community, and doing it in a localized fashion like San Jose is doing through their pilot is the right way to go. You know, they're going to convene a bunch of stakeholders around what makes sense for the community of San Jose when it comes to zero net energy. And it's not necessarily going to be the same as what makes sense in a different location. But along with that pilot, the city of San Jose is also working on key city policies that work hand in hand and basically push from both sides. Z&E on one side being the leadership kind of opportunity, and also bringing up the baseline, which we cannot forget, through things, common sense policy options like a required benchmarking and transparency ordinance, for instance, where all buildings over a certain square footage are required to track and report their energy use year over year. And we're seeing huge energy savings from run-of-the-mill everyday buildings in cities like Chicago, New York, Atlanta, through these kinds of common sense policies. So we need both, and not one to the exclusion of the other.
So where does this get us? I mean, we're in a position here. Like in the first 10 minutes, we've thrown out the concept of Z&E. So either what do we morph it into? How do we communicate that? And what really should we be focusing on? And I think another part of that is, who is we? You know, we are policy people, and we are designers, and we're people actually in the field on energy efficiency. I don't have, this is just an open question. You know, where do
there's some people in the room I know that I mean, this is at least I've seen some of the folks here that are pretty advanced thinkers in this space already, and to some extent we're preaching to the choir, I think. The couple of things that I think aren't well addressed yet, and I would love it if some of the either municipal agencies or utilities started to engage in these, or maybe if you already are, if you could kind of engage in us as a panel later on. And those are two things. One is the misalignment between zero net energy efforts or energy efficiency efforts at all and climate change. So we continue to use historic climate data to do all of the case-based work in the code, as well as the incentive program incentivization, rather than recognizing that the climate is changing and basing those incentives and that code on probabilistic versions of the future. That's a misalignment, and we should be better. California should be better. The second is that the carbon has a time value, and we're not recognizing that time value in California right now. We're stuck on an operational view of carbon, and I think in many municipalities still, we're not thinking about the embodied carbon in the construction side, and to some extent scope 3 emissions, and that really we should be doing a better job on. So those are two things. If we kind of leave aside the transit-oriented development and we assume that zero net energy is kind of happening in California, at least from a community choice aggregation standpoint, those two things are much more interesting and forward-looking to me than the conversation on Z&E, which seems to have been going on for about 4 or 5 years, and duck curve stuff. And
so should we really be talking about resilient buildings, resilient communities? I mean, and is that going to be the way the conversation goes?
So I think that's a great segue. So for example, we just finished up a project with the Department of Energy called Solar Resilient. And you can go online to solarresilient.com or .org. We own both, or the city of San Francisco owns both domains. And what that basically does is recognize that there's a misalignment or an opportunity maybe for alignment between emergency preparedness planning, solar, and storage. And that hasn't happened in the past, and we mapped about 250 different facilities in San Francisco alone, which is a fairly small city of about 800,000 people, right? So it's not a very big city. 250 facilities that don't have or have inadequate emergency backup. So in the event of an earthquake, should something like that ever happen in San Francisco, those buildings would be underserved and they would not function well as shelters and places that people could go for service. That includes things like dialysis centers. And so this is looking at how we can look at those buildings at a portfolio basis, put out solar energy, battery storage, link them with emergency preparedness planning, and give 250,000 people the opportunity to go and have a place where there is power during that type of an event. That to me is a very positive view of zero net energy approach to emergency preparedness planning and resilience. Sorry, I took a lot of time there.
That's okay. I think there's a lot of solutions that have to happen. I think there's some fundamental foundational issues that we need to address. And a lot of that I think has to do, with establishing the value and sending a price signal into this market, which I think is a big missing link. So if we're asking building owners to invest in zero net energy or load shaping resources or new HVAC, whatever it is, ultimately in their building, we're really creating a societal mutual benefit. And a lot of what we're doing right now, and this is a danger in policy, is to create prescriptive policies that basically takes a mutual benefit and concentrates it on the individuals willing to actually do the actual intervention. The people who are early adopters willing to actually do the work. They're paying for their benefit. They're lowering their bills. They're getting a more comfortable building, but they're spinning off all these mutual benefits, resiliencies for a city, carbon reduction. The utility doesn't have to put in a substation anymore, and we're expecting the individual to pay for it. So I'm a big believer that at a real foundational level, those mutual benefits that are accruing to cities, to agencies, to utilities need to be valued mutually, and that trying to force people to do things that accrue to others out of their own pocket is actually a very, very difficult thing to do and very expensive. And so a lot of the work we're doing is how do we value energy efficiency specifically as a grid resource, as a carbon resource. If you reduce electricity in your building, you're not getting a carbon credit. The utility's getting a carbon credit, right? So if we want people to do that, that benefit should be monetized properly. And so I think, to me anyways, we have to be careful of regulating too hard first before we kind of establish and align the interest properly in the marketplace.
But is that possible? I mean, these markets are moving so fast. I mean, the renewable markets are moving so fast. Some of the energy efficient technology is happening so fast. So
way more possible. So
right.
Some of the all source procurements that PG&E is doing right now, where rather than being prescriptive and saying we're going to give you a rebate for that furnace, and then we're going to spend the next 5 years regulating you and double checking your work. And by the way, by the time the program reaches the market, that furnace is out of date. And furnace is actually not a good example. Let's talk about an IoT device where by the time you get done with a 3-year work paper, that device isn't even in the market anymore. We're 4 generations past it. So we're already seeing and I think Dynegy, which is this substation in the middle of Oakland, is on the PG&E front is really one of the first major examples of replacing fossil fuel grid infrastructure without repowering a plant or running new power lines. And it really is this performance-based approach that says, look, we're not going to tell you what to do, market. We're not also going to we may also not directly engage the building owner. We're going to create an alignment of interest that says, hey, massive HVAC industry, Nest, program implementers are in the field. We'll pay you for your outcomes. Go figure out how to deliver them. Use the best technology. Iterate, compete, innovate, rather than kind of figuring out the solutions. And that's something I think we should think about: is how much of this is a policy choice, how much of it is policy people coming together to figure out how to fix buildings. I'm not a huge believer that's where the solutions come from. Actually, I think
I do that. I'm a huge believer of it, so I can give a
I'm a
converse
believer
view.
that if you make good outcomes very valuable and allow for innovation and competition, out of that will emerge the winning business models and the winning technologies, and that we do a pretty poor job of predicting that and codifying that into regulation. And I think we have about 40 years of history of that hasn't really worked terribly well.
I agree with you on the point about, we can't be prescriptive about you must put in this HVAC system because that will lead to success, and we promise, and that's why we're doing the regulation. So trust us. I think the value of policy, regardless of the market, is that the market is imperfect by nature. And so you leave behind a lot of buildings, you leave behind a lot of stakeholders if you don't also marry marketplace interventions with also policies, and you need both, not one or the other. I think one of the best policies right now on the books is actually the city of Los Angeles. So in December of 2016, in the city of Los Angeles, they passed one of the most ambitious local energy efficiency policies for buildings. And one of the pieces, aside from a benchmarking and transparency requirement, which is important because the market needs to know how well well or poorly all these buildings are doing, they have a requirement that says, hey, you are required to do an audit and retro commission your building every 5 years, or if you don't like that strategy, reduce your energy use by 15% in the same timeline, however you want. Just prove it. Just prove that you've done it. And I think that kind of approach where you have a performance standard that people are trying to meet, married with market interventions to make that maybe quicker, faster, more cheaper, makes a lot of sense, because what we do need is certainty that we can achieve the goals of, the Paris climate commitment, and even more ambitious goals than that, if we're really going to stave off the worst effects of climate change, which I think all of us, hopefully in California, kind of, want to do. And so we can't just rely only on the market to do that, without additional policy interventions for those that the market leaves behind.
So I'd at some level say policies and markets are very intertwined. The question is what are we regulating? When we're looking at how we send a price signal, how we construct these markets, it's actually very, very much a policy exercise. I'm working on the ground in a number of these cities, and I don't necessarily think that some of the policies we're implementing are necessarily having the effects in terms of driving the behaviors that we actually want, that they seem to potentially on the outside. I think we should use policy, and I think this is the way it was. We should use incentives and market design to drive the front end of the adoption curve, and then use policy to come in behind it. But I feel like we've flipped that in many cases, where we don't have a functioning market system. And this is what I was saying: this is not one or the other, but we don't have an incentive structure that says to a building owner, that doing this kind of thing actually works and makes sense for you. That we're telling them to invest a lot of money in benefits that are not accruing to them. And so I think we need to first rationalize the system and value things correctly, and then use policy to pick up the laggards, not force the hand of the early adopters, and a lot of things we've done in code are actually flipping that, right? Where code is driving Z&E and incentives are behind it and actually conflicting with each other. So I don't think of it as one or the other. I just feel like we need a fundamental platform that sends the right signal first, or at least at the same time.
Can we add some follow-up thoughts on that?
Yeah, that makes perfect sense. I think that there are times when the policy will create that anchor, and I think what I'm hearing is like there's a concern that the market should go first, and then we should follow up with policy rather than have policy be that potential anchoring point. There are some very successful case studies around when policy has been a successful anchor, and if it's not being a successful anchor in what we're doing, we should be fixing it. But one example is, fuel standards for cars. The auto industry was never going to actually have really ambitious MPGs, standards for cars without the federal policy to do that, because they don't have any incentives to change their entire operations, without that kind of a regulatory push. And I'm curious, I don't know if buildings are the same way. Are the market forces significant enough, to create that organic experience, or do the buildings, similar to the car industry, like need that push, that anchoring? I think that's the moment we're in right now, and that's where all this like messiness is happening.
I think that's challenging, though. I think that part of the challenge of buildings is that they really all are snowflakes. They all are unique. Where cars, it's easy because every car is largely the same, right? A Honda Civic. You buy a Honda Civic, I buy a Honda Civic. It's going to be pretty much the same entire performance. Where is you buy a building, I buy a building. Over the course of the life of that building, it's going to completely drift and change. And so it's harder. It's a harder kind of analog to have. Although I see that the overarching performance standards need to be more sophisticated.
But I do think there's so if Ford and GM are paying your gas bills, right, for your car, that might be a different story. And I do actually think that's the way we're going in buildings, that that most building efficiency and work is being sold, not bought, fundamentally. So, one of the transitions I see is things like energy services contracting that aligns incentives, but even at a more meta level, in these like all source procurements and pay for performance programs that are emerging here, particularly here in California, New York, some other states, it's actually not directly going to the building owner anymore. It's actually a cash flow to the aggregator. So I would like to see us enter a world where Trane, let me just pick on a big HVAC company, understands that producing efficiency that is valuable to utility is a new source of revenue for them, and valuable, and a way to make money. And they start taking interest in them, and they get a benefit from increasing the efficiency of their fleet and driving higher efficiency in how it's implemented in the buildings. And so, again, it's this alignment issue. I was a contractor, and I'll tell you, if my customer got a $500 rebate for putting in a furnace, I made the most money by doing the worst possible job I could possibly get away with. We didn't do that, which was part of the reason it was really hard to survive, actually. But the incentives are misaligned. right? And so we need to alignment. We need to make the right outcomes valuable, and align the incentive structure, and that allows us to do less prescriptive regulation when you do that.
I want to shift the conversation to something, Cole, you had mentioned earlier. The concept of embedded energy is something that is I think that in the Z&E discussion was pretty foreign a few years ago, but I think it's starting to increase. And part of the context of that is associated with where things like scope 3 emissions come into conversation, where scope 3 emissions are really indirect emissions associated with your operations. So I'm wondering if you guys are looking at embedded energy and how that could relate to energy use in buildings.
So yeah, so there's actually it's exciting because for a long time the zero net energy conversation really was dominated by, I'd say, architects and mechanical engineers. And over the last 5 years, the structural engineers and to some extent the electrical engineers, when it come into resilience and electrification, have come into their own. But the structural engineers are really engaging with embodied carbon in the buildings.
Mm-hmm.
And there's Carbon Leadership Forum that exists and is pulling together a lot, very similar to actually the operational energy view of the world, which is that you have a benchmark, you improve upon that benchmark, you have transparency of data, you have collection of that data across a lot of different owner types of buildings, aggregation and binning of that data, and it starts to create a rich data set that then you can work against. And the UK did some work on it about 8 years ago with Arup. MIT did some work about 5, 6 years ago, and that's all kind of moved now in the direction where we can start to truly benchmark buildings. And I would say that time is ripe to start looking at policy for it. And I don't know if you're working on that at NRDC. I think that would be an exciting thing to collaborate on, actually. Gil, I see in the front. I mean, you guys would be fantastic to take that on. Maybe you're already doing it. That to me is an untapped resource, and it's a huge opportunity value.
Right.
And we should clarify maybe for what we mean by the time value.
Can you just go a little deeper into what?
So most folks will already know time value because you have a bank account and you put money in the bank, or you make an investment out of it, and you say, well, it's $1 worth today. $1 today is worth more than $1 received 10 years from now. Right, so that's time value dollars. Time value carbon is basically the same analog, and whether you look at an interest rate or a discount rate or a minimum acceptable rate of return, all of those things speak to the same thing, which is a time-based value, where it's better to have it now, better to save it now than to have it in the future. And that goes directly to resilience and making sure buildings don't fall down. Right now, we have a life safety view of buildings rather than a performance view of buildings and seismic events. That's stupid. And the rating system, READY rating system, is a fantastic example of trying to get people to think a little bit about resilience in buildings a little bit more effectively. But yeah, so that time value, it's better to save the carbon now than it is 10, 20, 30 years from now. So we look at buildings on a total carbon basis.
Right.
So we aggregate operational carbon, embodied carbon, and transportation related carbon in order to aggregate those three into a total carbon profile for the building.
So that really emphasizes the need for transit oriented development. Then I mean that probably comes up.
Hell yes,
right.
Yes, absolutely. And actually, I'd say transit oriented development that is considered a future climate. Right. So it's all part of a system, and future climate seems to be sidelined too often and not thought about. We think about things in the historic context too often. Sorry, I'm jumping in.
No. That was my point. Is that part of what you're mentioning with talking about the time value of carbon and looking at the long term view of accounting for it gets to this broadening of the envelope. So we're no longer talking about building energy. We're no longer talking about building carbon. It's really the greater context. And I mean, one thing that we're seeing when we work with some of our clients who are trying to devise science-based targets for their operations, either they want to sign up for a science-based target, is that they're really challenged by the scope 3 idea, but they are warming to the idea that maybe not the right word. They're getting accustomed to the idea that this is actually a potential source of risk and opportunity, and so thinking about embodied carbon actually starts that conversation. That if your employees are having to drive to work, that actually does put risk on you.
But I wouldn't characterize the employee transit to work as embodied carbon. I would associate that with transportation related emissions. So okay. That's just how we try to organize it for ourselves, because we're speaking to different usually different technical experts in the conversation, right? So the transportation-related planners, future of parking, that kind of stuff has one segment of the conversation. The structural engineers and life cycle assessment, and what green building, the USGBC is trying to do around life cycle assessment has another slice of the conversation. And then you've got the mechanical engineers and the architects, to some extent, who are focused on the operational side. But all three of those things can fit together.
So are we headed towards? I mean, are we headed towards a situation where, at some point in the future, we'll have one metric, and that metric is carbon in 2100. That everything will be summed up to that for every project.
It sounds a little like a carbon tax, which
I
actually.
mean, I'm not going to put any labels on it.
Which I don't mean. I mean,
No.
actually, it's almost when you start talking about the complexities here at some level, the number of stakeholders and the amount of interconnected complexities that we're talking about.
It grows.
Yeah, and it's begging for a unified signal. Above my pay grade, but
Yeah,
it's a vast simplifier.
it is. It
It's
is.
really bottom up, top down, right?
And actually, just to make a political comment here,
We're in a city hall, so I think you're welcome.
Milton Friedman had a fantastic, if you go back, Phil Donahue and interviewing Milton Friedman, I guess it was in the early 80s, had a fantastic bit about arguing for a carbon tax. And if people know Milton Friedman is the champion of free market. So if you ever, I don't know, Republicans, Democrats, there's huge alignment on this issue. And I think that there's an opportunity for a conservative Republican view of the world, which is better or at least complementary in its approach to fixing this problem. And the liberal view tends to be dismissive of the conservative view, or the conservative view tends to be maybe not remembering that conversation that Milton Friedman would champion. But there, I think, is a common solution, and we need to come together around the solution rather than be separate and diminutive of each other.
So then bringing it back to the present, and I want to just get a couple of your comments, and I want to open up the floor to get some feedback from the audience. How do we then prepare for a situation where we might have a carbon tax? We might have people accounting for carbon. How do we deal with that when it comes to designing, operating, and implementing buildings?
We did a carbon tax adder analysis for a project at Stanford about 2008, so 10 years ago now. It didn't really change the outcome. So the ironic thing for me is that it added about a penny per kilowatt hour when we were looking at we only looked at operational in this particular sense. And when you looked at the return on investment for the building, it barely shifted it. So for that analysis, it was really telling to me that we look at some things like these as panaceas, as solutions, when in fact I think it's in one level it's like they're not a big deal, so they should happen very easily. But because there are very entrenched siloed interests that say, no, it works against my particular concern, they don't move. And yet for the vast majority of us, it doesn't matter. It's actually not that much money, and it won't change the game very much. But we can't. But it's like it's a great irony that it's a subtle change, but we can't make it happen.
It won't change business decisions, but
For that project, I'll say for that project, and I should highlight that was only one project, but it was an interesting example where it changed the payback from about 4 years to about 3.5 years. So that on a return on investment basis, you could say the owner doesn't care, right? That's noise.
Carbon and retail rates, it takes an enormous price to affect retail rates. It's very little impact, but there's these other benefits. I mean, this is where I think if we can mutualize all of the many benefits, it very well may be likely in many cases that shifting load, which is really the future of energy efficiency, is load shifting, not reduction in a traditional sense, because if you shift load, you can even increase consumption and have carbon benefits. But there are these other benefits. It could be, frankly, that load balancing to enable more renewables saves a lot more carbon than what your reductions are on your site. It's a much more macro view. And we're also looking, and for the first time, actually, we're just now, there's a process in California called CalTrack that's coming to a close where we're standardizing how to convert AMI data into measuring time and locational impacts of energy efficiency, which is a very different view where it's not savings, it's time and locational savings. And as we start converting that to carbon, we do see these very, very large swings between 7 p.m. carbon during the neck of the duck and 3 p.m.
So if we can start to monetize that, and I think a lot of that won't be at the building level. There, you even have measurement problems on individual buildings because of we're trying to get down to individual hours. But there'll be wholesale price signals that will ultimately trickle down to the building owners in the form of controls solutions that actually affect the time derivatives that we're generating that mean we're able to balance load and not. I mean, it'll trickle down to the stuff that actually performs better from a carbon standpoint, and a grid benefit will just be cheaper to the end customer. They won't be experiencing it through retail rates, which will always be a laggard because these grid signals can be really extreme, and like your neighbor could have a power line that goes the other direction and have a very, very different signature. So partly I think we need to get out of the individual building and start thinking about aggregation. And anyway, but I do agree though when you
G&E has left the building.
So I just don't want people to think that like a carbon tax wouldn't be revolutionary and paradigm shifting, because it actually totally will be.
stuff gets really bad, it'll go up.
But not from an individual building level, but actually that's all the more reason to have that price signal, in the sense of, if it's not going to be onerous for a building owner, but in the aggregate be revolutionary, because you can take that pool of funds and deploy them in spaces that desperately need deep energy efficiency retrofits. You get more you get more energy consumption off the grid that way. And so I just want to be clear, like, don't leave this panel saying carbon taxes wouldn't do anything, because they would totally revolutionize and be awesome at the aggregate level.
And the other thing is that current price, like right now, we're like, oh, $30 a ton, that's a lot. 60, that's a lot. But like we're on the verge of some really major changes, and so like from a market economic standpoint, like supply and demand is going to get very real. There's going to ultimately be a massive demand for carbon reduction because we have to do it, and we'll see value and price rise. We have to.
So I want to take some time. I see Gil is eager, and we have a number of minutes. So Gil, what are your?
You can use this one.
Yeah, sure.
Did you pass it around? Do you want to walk around?
Yeah, I can walk around.
Yeah.
Yeah, I'm Gil Friend from City of Palo Alto. Thank you. Really interesting panel and very provocative stuff. I want to follow up on the carbon adder and carbon tax conversation. So we've introduced a carbon adder in our fleet purchasing analysis. City of Palo Alto operates about 600 vehicles, has a municipal utility, so there's an interesting constellation of forces there, but we don't have the kind of data that Matt's game depend on. We're like 5 years away from smart meters, so we don't have time of use and so forth. So we've introduced a carbon adder into the fleet cost effectiveness analysis of what to purchase. And like you found with Stanford, it's a very small bump. It's notable, but it's not something that changes the decision. We're using the federal social cost of carbon.
Which is what? What is
Which is
that?
currently $35 a ton. It'll go to $50 a ton in 2050. And as a social cost of carbon, it's a kind of bottom-up analysis of what can we discern as the current impacts of carbon in society. Sweden's taken a very different approach, much more like Matt is talking about, and they said, since we need to move to a low-carbon society, what price of carbon would be necessary in order to drive the economics of the decisions and the directions that we want to go? They set the price at $200 a ton. 120, I think, moving to 200. I'm not sure exactly where it is, but way out of the boundaries of the usual conversation that we had, because they weren't trying to say what is so, they're trying to say what do we need? What are the leverages that drive that in that direction? And so we're encouraging our analysts, as we start to try to build a carbon adder into our capital budget process as well, it's one of my projects, uphill projects for this year, is to encourage the analysts to at least include a sensitivity analysis for the price of carbon, to say, what difference would it make if you use 12 or 30 or 50 or 100 or 200? And then you can start to have a political conversation, which is what it ultimately is, about what do you want to do. But it needs to be based on information that actually matters. So thank you all for teeing that up so well.
Great comment.
Other questions? Please introduce yourself.
Sven Thiessen here. I wanted to go back, sort of the premise of this was zero net energy buildings, and my question is, when the heck is California, which seems to be so so much efforts at working to save the planet is still allowing utilities to install natural gas lines in new residential developments. And you're speaking both as myself and my wife, who said to make sure to tell you guys this, that she's lived for now nearly 8 years in a natural gas free home, all electric and without an air conditioning, and loves it.
So we can safely not speak for utilities. So
I'll make a comment about it. I think it's you know, there's the I gave a presentation to the Behavior, Energy, and Climate Change Conference on how people make decisions, the psychology of the choice that we were seeing in the architectural community, and we talked a lot about the default condition, which is just kind of the habit, the normative choice, and to me it goes a lot to that normative, because we had a project just within the past 6 months at a major university, 1,300 bed new residential tower. I mean, you imagine 1,300 users, right? 1,300 occupants in this building. And we did an analysis comparing the cost of electric cooktops versus natural gas cooktops. And it was cheaper for them to take, because of all the gas line that they would run in this building, that it was less first cost to take those natural gas lines out of the building. They still were going to have it for the fossil fuel boiler in the basement, which is a whole other conversation. But we said we could take them out. It'll be less first cost. There's a small bump up in the electric ranges. We made a case for induction cooktops, and that's a whole other thing. And we told them, students don't cook anyhow, so it doesn't, it's not even going to be used. We got them convinced. We exited our role on the project. About 2 months later, they went back to natural gas. And it was what I heard, and we're kind of going back and going this conversation again, is that is what the facility staff were familiar with. That's what they'd done on every project previously.
I've said just straight ban from a policy perspective. It's sometimes easier just to say, this is a stop sign. You stop here. You don't go this way.
So politically speaking, you can, decarbonization of buildings can happen through usually heating or cooking. People are much more okay with decarbonizing heating than cooking. You probably all have someone who's a chef in their life who will swear by their gas stove, and trying to extract that stove from their house is a non-starter. Like, relationships will end if you do that. Whereas people don't necessarily feel that way about heating. They don't care. They just want to be warm. And so I think the cooking part will have to come with a large campaign around how awesome it is to not cook on gas stoves before that actually can happen, or else every city council member who votes in favor of that kind of local ordinance will get kicked out as of this moment.
So we work for we work for gas utilities, gas and electric utilities, and electric only utilities. So you can guess in that mix who's really excited about electrification right now. One of the interesting pieces is that, load growth as a reference to GDP is declining in the electric industry for the first time ever. So just like the rest of our economy, it's a Ponzi scheme, right? It's supposed to grow forever. So this is a big problem. So there's actually so depending on who your allies are, if you're an electric utility, you basically love electrification. You get to decarbonize and look like a hero while rebuilding your load, which is actually a very good thing. The challenge, I would say, and I don't have the answer to this, we were in the hall discussing, I use the jigsaw puzzle analogy. I feel like how all of these things fit together, efficiency, storage, electrification, EV infrastructure. It's an upside down jigsaw puzzle, and we're just starting to turn over the pieces, trying to figure it out. So the question, and I am actually all for electrification. But the big question from what it does from a grid carbon standpoint is that when you put an electric water heater or go to a heat pump, it's not a
it's not just a flat line. You're creating a new load shape, and how do these things all fit together? Is,
Right.
is going to ultimately be the big question. And like I said, I'm for it, but that's the big thing that I'm. It can be. I think macro, it has to happen. How it actually integrates with all the other efforts remains to totally be seen.
Right. So there's a grid impact to electrification.
Right. And it can be really great. Like electrifying water heaters is like the biggest no-brainer of all time. Like it's the easiest way to store thermal energy. I mean, that's a no-brainer. The electrifying heat is not quite as easy to think about quite yet, and how that integrates. And like I said, I think it's a good thing, but again, it's this integration problem. It has to work with everything else we're doing, or it can actually cause harm.
Right. Any other questions? I see a woman over there. Yeah. And please introduce your who you are and who you're with.
My name is Pui. I'm from the CPUC. My opinion doesn't reflect that of the PUC, just in case. I have to say that first. So a comment and a question. So first, the comment is, so you were talking about how you need policy to drive, and I agree with that. Certainly, like the policy of back in the days, the increase in the fuel economy definitely have improved the fuel economy of those electric fleet. But at the same time, back in 2009, for example, or 2010, our oil price was like about $100 per barrel, and it it definitely the market drives a lot of people want to save on the fuel cost, and I think the two combined definitely help drastically increase our fuel economy, right? And so my question is a little bit different on the community choice aggregation. Um, what I'm just looking at it recently. I was just thinking when there's a spiked rate, and if we have more and more customers leaving utilities IOU to community choice aggregation, and when it comes to a spiked rate, it could be a financial burden to the CCA. And would would that be an impact to the customers of community choice aggregation because it will be more expensive, or the CCA would not procure enough energy
Do you guys want to take that or?
when it comes to a spiked rate in the market?
I mean,
Yes.
so I'm not 100% familiar with the total economics of community choice aggregators, but I do know that some of them are looking into storage as well, both in front of the meter and behind the meter storage, and that's something that can help buffer those spike rates. I mean, we will always have spike rates, and they will be at very inconvenient times. We know that's going to happen. Although I can bet we're going to have one this summer, between 3 and 5 one day. I mean, we kind of know that. So I think I have heard of CCAs looking into storage, being curious about what that means to them, and trying to understand how to prepare for that at all scales. That is not the only answer, but I think my impression about CCAs, and maybe you guys have some opinions on this, is that they're still trying to. They are young institutions, and so they're still trying to work some of the details of that out. They will probably be stung by a couple of incidents, but then they're going to be learning from those as we go. Some of these CCAs have very small staffs, and some of them come from experienced utilities, some of them not. So I think it's early days for CCAs to see how they can deal with something like that. But I think that if the more that a facility can, resilience isn't just resilience from energy; it's also price resilience too. I mean, if you can buffer at a building scale your energy use and choose to use power when it is both cheapest and most abundant, then you're going to be it won't be that as much of an issue when there's a price spike. So there's a financial resilience. There's also simply availability resilience that I think buildings can come into. Which kind of, I just want to keep our eye on the time. That kind of brings us back. I think Kimmy may be turning into a pumpkin. She's got a call, but I think the rest of us will be around for some rest of the day. So I want to thank you guys for coming here. Let's give the panel a round of applause.